Welcome to Course 2, Lesson 24. In this lesson, we're going to follow up on reducing fractions that we've already practiced a little bit on. We're going to use prime factorization to simplify those fractions, and then we're going to use the greatest common factor of two numbers to simplify the fractions before we multiply them. For this lesson, we do not have any new vocabulary. Anything we talk about, we should be familiar with and know the meaning of. The very first thing out of the chute is that it's going to ask us to use prime factorization to reduce 420 and 1050 and then find the greatest common factor of those two numbers. Now, what's different here is that it's in the fraction form right here. So you're going to have to factor out both of those numbers using a factor tree in order to reduce it to its smallest number. So let's go ahead and see how we do that. Once you do that, you would come up with that it factors out to 2 times 2 times 3 times 5 times 7 for 420, and 1050 has an additional 5 in there. When we take those, and you'll remember to get the smallest number, we cancel out. So this cancels out, these cancel out, these cancel out, these cancel out. So that leaves us just a 2 and a 5, or 2 over 5, or 2/5. I didn't give you time to actually do this yourself, although you could have. I just wanted you to remember to remind you how we do it, and then we're going to do some practice throughout this video. So to get our smallest reduced number, 2/5, we cancel out the numbers. So how do we find the greatest common factor of 420 and 1050 using that same factor tree and those same factors for each of those numbers we came up with? Well, the way we use the largest is just the opposite. We find the ones that are in common, our 2's, our 3's, our 5's, and our 7's. This time we're going to ignore the 2/5, and we're going to take, we know that we've got, both numbers have a 2, both numbers have a 3, both numbers have a 5, and both numbers have a 7. And we're going to times those together and get our answer. So we find that the greatest number, the biggest number that goes into both 420 and 1050 is 210. And that would be our answer for B. If we have a set of alphabet cards, including one card for each letter of the alphabet, and one card is drawn from that set of cards, what's the probability of drawing a vowel, including a Y? Now, you might have to read that 3-4 times to try to figure out what it's even asking you. So just slow down and let's pick it apart a little bit. So a set of alphabet cards, including one card for each letter of the alphabet. So how many cards are we going to have? If you don't know, then do your ABCs and count them. But that number is 26. We're going to have 26 cards. Then, if one card is drawn from the set of cards, what probability of drawing a vowel including Y? So we've got our A, E, I, O, U, and Y. So we've got 6 favorable outcomes that we could have. So we're just going to take that 6 and put it over the 26. Favorable outcomes versus total. So then we're just going to reduce 6 and 2 6. You can factor it out. What goes into 6? Factor that out. Figure out your numbers. And what goes into 26? 6 is 2 times 3, and 26 is 2 times 13. Is 13 prime? It is. So we're done. And that's how we do it. And then we just cancel out the 2's, and that leaves 3/13 as our answer for the probability of drawing a vowel, including a Y, when we draw one card out of 26. So when we multiply fractions, we often get a product that can be reduced, even though the individual factors can't be. So this fraction can't be reduced, and this fraction can't be reduced. But once we multiply those, and we get 6 and 24ths, that can be reduced to 1/4. But there's a way of doing it before you multiply, so you're not dealing with this big number of 6 and 6/24ths. The way you do that is it's known as canceling. And to reduce any numerator, you can reduce any numerator by pairing it up with any denominator. It doesn't matter which one. Below, they've paired up the 3 with the 3 and the 2 with the 8. And as you can see, if you take this 3 and that 3, it ends up with 1. And that 2 goes into 8 4 times. right? And then we just multiply. 1 times 1 is 1, and 4 times 1 is 4. So our answer is 1/4. So we get to this much easier by canceling than by multiplying and then reducing the larger number. So simplify 9/16 times 2/3, use canceling, and let's simplify 8/9 over 3/10 and 5/4 using canceling. So go ahead and stop the video, do it, and let's see if you got it right. In our first problem, you can pair up your 3 and your 9, which cancels it down to 1 and 3, and we'll pair up our 2 and our 16, which gives us 1 and 8. And then we just multiply across, and we get 3/8. Now, on the second one, there's a lot of ways you can pair this up. You can pair up your 8 with your 8 and your 4 over here, the 5 and the 10. You could do it that way. That's one way you could do it. Another way you could do it is that you could pair up the 8 and the 10, the 3 and the 9. Do that, take your answer, then pair it up again with the other ones. So there's a lot of ways you can do this one here. It's up, you go ahead and figure it out. Try which way you think works best for you, and then we'll take a look at the answer. All right, so if you pair them up and start to reduce, let's go ahead and do our 8 and our 10. 2 goes into, well, they did 8 and 4, it looks like. 8 and 4. The 4 is 1, the 8 becomes a 2. Here, the 3 becomes 1, the 9 becomes a 3. Here, 5 and the 10, the 5 becomes a 1, and the 10 becomes a 2. And then you look at that, you still got this 2 and this, now you can still pair these up, right? The 2 is a 1, that's a 1. Now, 1 times 1 times 1 is 1, and 3 times 1 times 1 is 3. Our answer is 1/3. So they canceled, and then they had one additional cancelization you had to do right here, and you come up with 1/3. So a lot of canceling in that particular problem. Isn't that a much easier way of doing it than if you were to just think how hard this is? 8 times 3 is 24, times 5 is what? And this is 900, so 3,600 over, you don't want to do that. That's crazy. So reduce, cancel these out first. Do all your canceling first so that you're dealing with much smaller numbers. That's why we cancel. All right, so here's a good example of that. 27 times 20, that's a huge number. 32 times 63, that's a huge number. I don't want to do that. So you could use factor trees and lay them all out, or you can just, if you have good multiplication facts, let's go ahead and see what we can find in common. We know right here that we can make that smaller. The largest number I can think of that goes into 20 and 32 is the number 4. 4 goes into 20 5 times. 4 goes into 32 8 times. Now, what goes into both 27 and 63? Let's see here. Just kind of go through your numbers. Does 1, does 2, does 3? Oh, 9, right? 9 would. 9 goes into 9. Let's go 9. 9 goes into 27 3 times, and 9 goes into 63 7 times. Now, can we pair anything else up? Does 5 and 8 reduce, or 3 and 8 reduce, or 3 and 7? Nothing else reduces. So now we're just going to multiply across, and we get 15, and 8 times 7 is 56. 15 over 56, and that is our reduced fraction for those two when we multiply those together. This is how it looks if you had used a factor tree. If you use a factor tree for all of your numbers and then you started to cancel everything out, that's the same above, put a line right through there. So we've got this 3 will cancel out that 3, this 3 cancels out that 3, this 2 will cancel out that 2, this 2 cancels out that 2. So that leaves us our 3 times 5 is 15. And then we've got 2 times 2 is 4, times 2 is 8, times 7 is 56. So it works that way too. I like this what we did here initially. I like that better if you can see it. If you can't see the numbers, then you've got to do it this way. This will be the only way you can do it. Okay, that's the lesson. If you have any questions, bring them tomorrow to class. If not, go ahead and work on 3AB, 8AB, and 21. On 3AB, just give me your answers. Give me the answers. The chart you can go ahead and show on your homework. 8A and 8B you can show me. Remember that anytime you do it, just do 3/4 for your fractions. I know you cannot type that in, so do it this way here. And get these done. Get them sent in to me tonight, and we'll see you tomorrow in class. Thank you for watching the video.